Let's look at page 2 of your quiz. So this is potentially one of your questions. If not, I'll do your question 3 in just a second. If we look at this question here, we're asked to determine an equation for each parallel line described by transferring both point-slope form and slope-intercept form. Okay, point-slope form is of the equation y minus y1 equals m times x minus x1. That's your starting point. And slope-intercept form is y equals mx plus b. That's where the equation ends. Okay, so if you saw that and you got really confused, we've been doing that the entire time. So let's look at this question. What is the equation of a line parallel to y equals negative 5x plus 3 that passes through this point of 3, 1? Okay, so when we're looking for an equation of a line that's parallel, you have to know that your slopes are going to be the same. So my slope here is negative 5. So the slope of a line that's parallel to this will also have a slope of negative 5. Okay, now my ordered pair is given, so that's my x1 and my y1. And now I'm simply using my point slope equation that says y minus y1 equals m times x minus x1. And I'm substituting my given information in. Okay, so I'm going to substitute this negative 5 for my m. So I have a negative 5 for my m. I'm going to substitute this 3 for my x1. And I'm going to substitute, let's pick a different color. I'm going to substitute this 1 for my y1. Okay, and I've got my equal sign here. So now my next step is going to be to distribute. So I have y minus 1 is equal to negative 5 times x is negative 5x, and negative 5 times negative 3 is a positive 15. Okay, and then I would add 1 to each side, and I get that y equals negative 5x plus 16. And this is my slope-intercept form, and this here is my point-slope form. If you had this equation, you're going to do the same thing. Write an equation of a line that is parallel. Okay, so if it's parallel, I know my slopes are going to be the same. And my current slope is 7. Therefore, the line that's parallel to it will also have a slope that's 7. This is my x1 value, and this is my y1 value. So I'm going to use my equation that says y minus y1 equals m times x minus x1, and substitute and then solve. So I have y minus a negative 2 is equal to 7 times x minus, that should just be x minus 5. Okay, my next step would be to distribute or simplify a little bit, but I can simplify my left side by saying that y minus a negative 2 is the same as y plus 2. And then on my right side, I'm going to distribute that 7. So I have 7 times x, which is 7x, minus 7 times 5, which is 35. My next step would be to just subtract 2. So I'm left with y equals 7x minus 37. And that would be my equation of a line that's parallel to y equals 7x minus 8 that passes through the ordered pair of 5, negative 2. Now, what is the equation of a line perpendicular to y equals 2x minus 6 that passes through the ordered pair of 5, 4? Okay? Perpendicular lines have slopes that are opposite reciprocals. So if my slope here is 2, the opposite reciprocal of that would be negative 1/2. So my slope would be negative 1/2. The 5 is going to be my x1. The 4 is going to be my y1. So I have my equation that says y minus y1 equals m times x minus x1. If I substitute my information in, I have y minus 4 is equal to negative 1/2 times x minus 5. And now I'm going to distribute. So y minus 4 is equal to negative 1/2 x plus, because negative times a negative is a positive, 5/2. My next step would be to add 4 to each side. And when I add 4 wholes to 5/2, I get y equals negative 1/2 x plus 13/2. Okay, so let's look at that if you don't understand this part right here. Let's talk about it. So 5/2 plus 4 over 1. I have to get common denominators when I add fractions. So I have 5/2 plus 8 over 2, because 8 over 2 is the same thing as 4. They're equivalent fractions. And now that I have these common denominators, I can simply add my numerators. 5 plus 8 is 13. And I keep my same denominator of 2. So that's where that 13/2 comes from. So write the equation of a line that's perpendicular to the given line that goes through the given point. Okay, again, perpendicular lines have slopes that are opposite reciprocals. So my current slope is negative 4, so the perpendicular line would have an opposite reciprocal. The opposite of negative is positive, and the reciprocal of 4 whole, we can always write that as a fraction by putting it over 1, would be positive 1/4. So my slope is 1/4. Now my point is x1, y1. So I'm going to use my equation that says y minus y1 equals m times x minus x1. If I substitute my given information in, I have y minus a negative 2 is equal to 1/4 times x minus a negative 1. So that's y plus 2 is equal to 1/4 times x plus 1. And if I distribute my 1/4, I have y plus 2 is equal to 1/4 x plus 1/4. And now I'm going to subtract 2 from each side. And when I subtract 2 from 1/4, that's the same thing as saying 1/4 minus 2 over 1, or 1/4 minus 8/4, which is a negative 7/4. So my equation is y equals 1/4 x minus 7/4. So this equation, y equals 1/4 x minus 7/4, is perpendicular to the line negative 4x plus 11, and it goes through the point of negative 1, negative 2. Okay, so if you wanted to be a level 4 here, I asked you to find the distance from the point to the line. Your first step was to find the equation, which you should have already. Your second step is to find the point of intersection. Now the point of intersection means between your two lines. This is one line, and this would be your second line. So to find the point of intersection, we know that we can simply put our two equations equal to each other. So if you put them equal to each other, we have negative 4x plus 11 equals 1/4 x minus 7/4. Okay. Now I highly suggest that you clear your fractions. Most of you don't like dealing with fractions, so we can clear our fractions by multiplying both sides of our equation by the common denominator. Now my denominator happens to be a 4, so I'm going to multiply everything by 4. Now when I'm talking about everything, I mean both sides of my equation. So now 4 times negative 4x is negative 16x. 4 times 11 would be 44. So I have negative 16x plus 44 is equal to 4 times 1/4 x is simply x, and 4 times negative 7/4 is going to be a negative 7. So I have negative 16x plus 44 equals x minus 7. Now I need to isolate my variables to one side of my equation. I can do that by subtracting both sides by x. And if I do that, I have negative 17x plus 44 equals a negative 7. And then I would subtract 44 from both sides, get negative 17x equals a negative 51. And I would divide both sides by negative 17 and get x equals 3. So if x equals 3, what is y? Well, I simply use one of my two equations and substitute a 3 in for my x and get my get my y value. So the easiest one to use is going to be that equation that said f of x is equal to negative 4x plus 11. So I know the same thing, that f of x is negative 4x plus 11 means y equals negative 4x plus 11, because this is a function of x, and so our output is going to be our y value. Okay, so I have y is equal to negative 4 times 3 plus 11. Negative 4 times 3 is negative 12. Negative 12 plus 11 is negative 1. So my y value is negative 1. Now remember that these are the parts of an ordered pair, and an ordered pair has both an x value and a y value. So my intersection point is the point of 3, negative 1. Now I'm going to find the distance between this point and my given point, and my given point was negative 1, negative 2. Okay, so now I'm going to find the distance. My two ordered pairs are 3, negative 1 and negative 1, negative 2. Yep. So my distance equation is the square root of x2 minus x1 squared plus y2 minus y1 squared. So x2 minus x1 is going to be, I can let this one be my x2, y2, and I'll let this one be my x1, y1. So I have 3 minus a negative 1 squared plus negative 1 minus a negative 2. Sorry, I ran out of space over here. Let me zoom in a little bit. Maybe I can write a little smaller. That's a big mess. So 3 minus a negative 1 is going to be 3 plus 1 squared. And then over here I have negative 1 minus a negative 2, which is going to be 1 squared. And this is the square root. So 3 plus 1 is 4. So I have 4 squared plus 1 squared. 4 squared is 16. 1 squared is 1. And 16 plus 1 is the square root of 17. So this is approximately just over 4. 4.1 units. Okay, if you had the other question, you do exactly the same thing. Let me zoom out a little bit. Okay, my two equations are y equals 2x minus 6 and y equals negative 1/2 x plus 13 halves. Okay, so if I set these two equations equal to each other, I have 2x minus 6 equals negative 1/2 x plus 13 halves. And let me zoom in so I can write a little neater. My first step would be to clear my fractions. So I would say 2 times 2x minus 6 equals 2 times negative 1/2 x plus 13 halves. Now this is exactly the same as what I did on the other page. I just put parentheses around my entire equation, and this time I just used each side of my equation. Okay, but I'm doing the exact same thing. So now 2 times 2x is 4x, and 2 times negative 6 is going to be that negative 12, equals 2 times negative 1x is just negative x, and 2 times 13 halves is 13. Now I would move all my x's to one side, so isolate that variable term. So I would add x to each side. So I have 5x minus 12 equals 13. And then I would add 12 to each side. So I get 5x equals 25. And then you would divide both sides by 5 to solve for x. So you have your x value. but you need your y value as well. So let's use this equation here that said y equals 2x minus 3. So if I have y equals 2x minus 3, and I'm substituting this 5 here for my x, I get y is equal to 2 times 5 minus 3, or 10. Oh, sorry, I don't know why I have a 3 there. Sorry guys, that should be a 6. 6 and 6. So 10 minus 6 is 4. So my point of intersection is 5, 4. Okay, so this is my point of intersection, and I'm looking for the distance between 5, 4 and my line. Okay, well, this isn't a trick, but what is the distance between the point 5, 4 and 5, 4? It's 0. So if I used my distance, I can prove it, x2 minus x1 squared plus y2 minus y1 squared. So x2 minus x1 is simply 5 minus 5, and y2 minus y1 is 4 minus 4, and 5 minus 5 is 0, and 4 minus 4 is 0, and the square root of 0 is 0. So the distance between 5, 4 and my line is 0 units, because 5, 4 happens to, that ordered pair of 5, 4 happens to actually fall on that line.